All right, taking a look at problem one. F of x equals x over x minus 4. We want to know the domain. Which x's can we use? Well, we have a restriction here with a fraction. What can't happen with a fraction? You can't have a 0 in the denominator. That means we cannot have that x minus 4 cannot come out to be a 0. We can't let that happen, because if it does, then you're going to have a 0 in the denominator, and that will mess everything up. So we add 4. X can't be a 4. So x can be anything except 4. We just can't have it be a 4. So what do we say the domain is? The domain is all real numbers except x can't be a 4. That would be the domain. Everybody, you can plug in any number and get a solution except 4, because 4 minus 4 will give you 0, and you cannot divide by 0. Problem 2. Is it a fraction? No. Is it a square root? No. That means anybody works. That's all real numbers. No matter what you plug in, you're going to get a solution. There's no restrictions here. 3, have a fraction. What can't happen to a fraction? This bottom cannot be a 0. So we solve it, subtract 5. X cannot equal a negative 5. So the domain, the pieces at work, everybody, all real numbers, except x can't equal a negative 5. Ooh, a square root. What can't happen in a square root? You can't have a negative. You cannot have a negative. That guy must stay bigger than or equal to 0. Otherwise, you don't get a real number solution. So when we have a radical, we simply take what's there and say, hey, you better stay bigger than or equal to 0. Solving it, we subtract 9. X has to stay bigger than or equal to negative 9. As long as x is bigger than or equal to negative 9, we'll get a solution. If it's not, let's say negative 10. Negative 10 plus 9 is negative 1. I can't take the square root of negative 1. So we write this solution as all real numbers such that x is bigger than or equal to negative 9. Whenever it's a radical, you simply take it and make sure that it stays greater than or equal to 0.